Okay, students, from carbonyl compounds chapter last class we have discussed 15th questions are completed from level 3. Let's see the next question. 16th question, how to solve this 16th question. This 16th question is nothing but alpha substitution of carbonyl compound. This is more acidic proton. So here two alpha carbons are present, but bromination, okay, means substitution, halogen substitution at alpha position, that bromine in the presence of acetic acid, and here the bromine in the presence of sodium hydroxide base. It is a polar solvent. So the bromine is more reactive and it is non-polar solvent. Compared to NaOH, weak electrolyte. It is a weak electrolyte. Acetic acid is a weak electrolyte. NaOH is a strong electrolyte. That's why its reactivity is less. Then only one alpha hydrogen will be replaced by bromine. The product is CH3, CH2, C double bond O, bond CHBr, bond CH3. If the Y, this is X product, and the Y is the strong electrolyte, then that two alpha hydrogens are replaced by bromine, then Br and Br. Now the answer is first option is correct. Okay, students. Let's see that 17th question. 17th question is important and easy also. CH3CHO, acetaldehyde react with 3 moles of formaldehyde. And what is X they're asked. Okay. See the 17th question. In the presence of base is nothing but cross aldol condensation reaction. Cross aldol condensation, aldol reaction. Cross aldol reaction. Okay, students. Let's see that CH3 C double bond OH reacts with formaldehyde HC double bond OH in the presence of base. See, this base removes this alpha hydrogens. How many alpha hydrogens are present? 3 alpha hydrogens are present, and it is 1 mole and it is 3 moles. So that's why here we need to take 3. That 3 moles means the negative charge will be replaced. It becomes CH2OH minus. Means this compound is CH2OH thrice C double bond OH. That is the final product. Let's see that CH2OH thrice CHO means the answer is a third option. Okay, this there is no alpha hydrogens. This product actually up to this only they are asked. This is the product. This is treated with base again 1 mole. One more base if you are treated, then it undergoes Cannizzaro reaction. It undergoes a Cannizzaro reaction. The product is CH2OH thrice C double bond O O minus plus CH2OH thrice C bond CH2OH, alcohol and carboxylic acid will get. Only just up to 3 moles only the reaction is given. Now then it involves in the same product is involved in cross Cannizzaro reaction because it is no alpha hydrogens, it can involve in Cannizzaro reaction. So now this reaction, the answer is third option. Okay, in the further it undergoes Cannizzaro reaction in the presence of strong base. Here Na2CO3 is a weak base, sodium bicarbonate is a weak base, but strong base is present. Strong base, it undergoes Cannizzaro reaction to produce acids and alcohol. Okay, let's see for next 19th question, dear students. It is important 19th question. The first addition of HOCl to the acetylene, CH double bond, triple bond CH, excess of HOCl we need to add. OH minus and Cl plus. You have to add that, then we'll get CHOH double bond CHCl will get. Now the another we have to add one more of HOCl, OH minus and Cl plus. Then the Cl is now it will be added at CH, OH, two OH groups at one carbon and two Cl groups at one carbon. Two OH groups at one carbon is unstable, loss of water molecule. Okay, is converted into CHCl to C double bond OH. That is A product. This is A. This A is again treated with chlorine because here alpha hydrogen is present. One alpha hydrogen, it will be replaced by the chlorine to produce CCl3 C double bond OH. That is B product, is known as chloral. Chloral. This chloral is further treated with base NaOH, NaOH, aqueous NaOH. It undergoes hydrolysis to produce means is the product of haloform test, chloroform. CHCl3 will get CHCl3 plus HC double bond O Na. This is a C product. The C is treated with concentrated HNO3, loss of water molecule, produce CCl3NO2, trichloronitromethane, trichloronitromethane. This is the final product. This is also known as a tear gas. It's very, very important, dear students. CCl3NO2. So what are the products A, B, C, D? Okay. So the A is dichloroacetaldehyde. CHCl2CHO. And C is trichloroacetaldehyde, is nothing but chloral, and C is chloroform. This is treated with concentrated H2SO4 to get trichloronitromethane, is also known as tear gas. So the answer is a second option. So this conversion is very, very important, dear students. Okay, let's see that 19th question. The 19th question is methyl cyanide is treated with sodium in the presence of ethyl alcohol. C2H5OH is a reducing agent. It reduces cyanides into amines. Okay. It produces nascent hydrogen atoms and the cyanide group is converted into CH3 bond CH2 bond NH2. Cyanides are converted into primary amines. Again, this is treated with HNO2. This is treated with HNO2. Loss of water molecule is converted into diazonium salt. CH3 bond CH2 bond N2 plus and OH minus. This diazonium salt, aliphatic diazonium salt, aliphatic diazonium salt, unstable, okay, is unstable, converted into alcohol, loss of N2. The product is CH3 bond CH2 bond OH. Ethyl alcohol is the product. Now this is treated with PCC or PDC. PCC or PDC or MnO2, manganese dioxide, are the mild oxidizing agents. They oxidizes primary alcohol into aldehyde. So the product is CH3 C double bond OH, acetaldehyde. So the final product is a acetaldehyde. So the answer is a fourth option. C. Listen dear students. First cyanide CN group is treated with sodium metal in the presence of ethyl alcohol. It cyanide group undergoes reduction to gives primary amines. The primary amines are treated with nitrous acid NaNO2HCl produce nitrous acid. It is unstable. That nitrous acid aliphatic primary amines reacts with HNO2 to forms diazonium salts. That salts are unstable, immediately converted into alcohols. That alcohol, primary alcohols treated with PCC or PDC or MnO2 is converted into aldehydes. So the answer is a fourth option. Okay, is very very important, this type of conversions. Let's see the 20th question, dear students. 20th question, among that which compound will be produce aldehyde? Okay, so which will produce aldehyde, we need to identify that carbon and carbon having double bond is present, and each carbon has two methyl groups are present. At each sp2 carbon has two CH3, symmetrical tetrasubstitute alkane. This we are doing ozonolysis followed by reductive ozonolysis, treated with ozone. Then immediately what will happen, dear student, this double bond will be break and is converted into two carbonyl compounds, and here it is symmetrical CH3 and CH3. This is also CH3 and CH3 produce 2 moles of acetone, CH3 C double bond O CH3. So it is not aldehyde. Okay, first option is not correct. Now the second option, let's see. This is CH3 CH double bond CH2 is treated in the presence of CO plus H2. CO plus H2 is known as water gas. In the presence of cobalt or rhodium catalyst, either cobalt complex or rhodium carbonyl catalyst, then it is nothing but it is oxo process. Oxo process means alkanes converted into higher carbons containing aldehydes. Higher carbons containing aldehydes. Now it is converted into CH3 bond CH2 bond CH2 bond C double bond OH aldehyde. So the answer is the second option. Let's see third and fourth options why it is wrong. What are the products in third and fourth option? That also we'll discuss. CH double bond CH2 in the presence of water reacts with water in the presence of palladium chloride, and cuprous chloride is known as Wacker's process. Wacker's process then is converted into CH3 CH OH double bond CH2 enol is unstable converted into the final product is CH3, C double bond O, CH3. Ketone is the product. Okay, so the third option is also aldehyde ketone is formed. Fourth option, let's see, propane. That propane is upon hydrolysis in the presence of heavy metals, Hg plus 2 followed by H2SO4, then it produce one intermediate product CH3CH OH, OH double bond CH2. Addition of water according to Markovnikov addition rule. Markovnikov addition, then it is enol is unstable, again reconverted into ketone. The same like third equation. CH3, C double bond O, CH3. Now our answer is a second option. Okay, student. The first one is ozonolysis reaction. Reductive ozonolysis, tetrasubstituted alkenes are converted into ketones only. Now the second one is oxo process. In the oxo process, the reagent is CO plus H2 in the presence of cobalt or rhodium catalyst. Then that alkenes are converted into higher carbons containing aldehydes. See, the reactant has 3 carbons are present. The product has 4 carbons. Okay, that is known as oxo process. Next, third and fourth. Third one is Wacker's process. In the Wacker's process, except ethene. Ethene means ethylene. It gives only acetaldehyde, remaining all alkenes to produce ketones when that reacts with water in the presence of palladium chloride and cupric chloride, cuprous chloride, Cu2Cl2, CuCl2. Okay, so that is Wacker's process. Except ethene, the remaining all alkenes are converted into ketones, same number of carbons. And alkynes, except acetylene, the remaining all alkynes converted into hydrolysis, addition of water converted into ketones in the presence of heavy metals. Okay, let's see that 21 question, dear students. 21. See that calcium salts of carboxylic acids on distillation to produce ketones. That ketone is zinc amalgam HCl, Clemmensen reduction converted into alkanes. The 21 CH3 C double bond O, CH3 C double bond O minus and Ca plus 2 is on distillation. Upon heating, loss of calcium carbonate, produce CH3 C double bond O, CH3. Acetone is the product. This acetone is treated with zinc amalgam HCl, is known as Clemmensen reduction. Clemmensen reduction reaction, the C double bond O is converted into alkanes, CH3 CH2 bond CH3. So okay, acetone is converted into propane. So the answer is a second option. Okay, let's see the 22 question, dear students. What is the 22 question? The 22 question is select the compounds undergoes intramolecular Cannizzaro reaction. Intramolecular Cannizzaro reaction means both aldehyde groups, both carbonyl groups present in one molecule. Then that reaction is known as intramolecular Cannizzaro reaction. Intramolecular Cannizzaro reaction. Okay, students. Now let's see the first one. PH C double bond O, CH Cl2 in the presence of base. The presence of base, first it is converted into pH, C double bond O, CH, OH and OH. Loss of water molecule is converted into pH, C double bond O, CHO. Okay. Beta alpha keto aldehydes. Alpha keto aldehydes involved in intramolecular Cannizzaro reaction again in the presence of base is converted into pH. Always the ketone group is converted into alcohol and aldehyde group is converted into acid. Okay. Now the first option is involved in intramolecular Cannizzaro reaction. The second option, let's see, CHO and CHO. There is no alpha hydrogens and two carbonyl groups are present and one carbonyl group is converted into alcohol. Another one is converted into carboxylate ion. So the second one also involved in intramolecular reaction. The third one is CH3, C double bond O, CHO. Here the ketone has alpha hydrogens but aldehyde functional group doesn't have alpha hydrogens. Then it involved in CH3, CH, COO minus alpha hydroxy carboxylic acids. So the answer is A, B, C, D. Sorry, A, B, C. First one, second and third will involve in intramolecular Cannizzaro reaction. Let's see this fourth one. It involved in two molecules in the presence of base. In the presence of base, the products are CH2 OH bond CH2 OH. Another product is COO minus bond CH2 OH. Is only Cannizzaro reaction, is not intramolecular Cannizzaro reaction because that D compound CHO, one carbonyl group only present. Two carbonyl groups are not present. Okay, that's why D is not intramolecular Cannizzaro reaction. A, B and C. A, B, C means third option is correct. Okay, students. Let's see for 23rd question. The 23rd question is aldol condensation reaction. The 23rd question is aldol condensation reaction. Okay. See here alpha hydrogens, two alpha hydrogen atoms are present. It involves in 2 moles we need to take. Then 2 moles of cyclopentanone in the presence of dilute KOH. Upon heating, loss of water molecule is known as a aldol condensation product. Okay, aldol condensation product. Then this water molecule they will lose. The product is this is the product. So the option is a second option. Okay, students. Let's see 24th question. 24th question. Terminal alkynes having acidic proton is present. Bu means butyl group. Negative and H plus is treated with sodamide. NaNH2. Na plus NH2 minus. This NH2 minus removes this proton. This forms Bu C triple bond C minus and Na plus, means it acts as a nucleophile. It acts as a nucleophile. Okay, students. Now again this is treated with benzaldehyde. Benzaldehyde, it undergoes nucleophilic substitution reaction followed by hydrolysis. Then O minus and Na plus upon hydrolysis produce alcohol. The product is benzene CHOH bond C triple bond C bond butyl group. This is treated with MnO2, manganese dioxide. It oxidizes secondary alcohol into ketone and primary alcohols into aldehydes. Now the product is C double bond O, C triple bond C bond butyl group. So the answer is fourth option is correct. Okay, students. Let's see the fifth option. SCO2 is oxidizing agent. It oxidizes alpha carbon. It oxidizes alpha hydrogens. It oxidizes alpha carbon. Alpha hydrogen containing alpha carbon into C double bond O group of carbonyl compounds. Okay, selenium dioxide. Selenium dioxide means especially, for example, C double bond OH bond CH3. This is alpha carbon. This alpha carbon having carbonyl group. C double bond O group is present as CO2 oxidizes this alpha carbon into C double bond OH and C double bond OH. Like in the same way, ketones CH3 C double bond O then is converted into CH3 C double bond O C double bond OH. CH3 group are alpha carbons into carbonyl compound C double bond O group. 1 mole, then 1 mole of alpha carbon is converted into carbonyl group. Now the same way, whenever benzyl aldehyde, this is alpha carbon, this alpha carbon in the presence of selenium oxide, the X is equal to C double bond O bond CHO. It treated with base KOH involving in intramolecular Cannizzaro reaction. Molecular Cannizzaro reaction. Okay, in the intramolecular Cannizzaro reaction, the product is this C double bond O group is converted into OH and this is converted into carboxylic acid salts. Okay, so the final product is CHOH bond COOK. Okay, so the answer is first option is correct. Okay, students, let's see the next question. The 26th question. Sodium cyanide CH3 CH2 bond Cl, ethyl chloride treated with NaCN, it undergoes SN2 reaction. Product is CH3 bond CH2 bond Cn. Ethyl cyanide, this ethyl cyanide is on reduction in the presence of nickel H2. Then the Cn group is converted into CH2 bond NH2, primary amine will forms. Now the product is CH3 bond CH2 bond CH2 NH2. Primary amine, that primary amine is treated with acetic anhydride. CH3 C double bond O bond C double bond O CH3 means acetylation reaction. Acetylation reactions of amines takes place in the presence of carboxylic acids or acyl chlorides and anhydrides to produce amides. So the reaction is, the final product is CH3, CH2, CH2 bond NH, C double bond O, CH3. N-acetyl propanamide. N-acetyl propanamide is the product. Okay. Third option is correct. Okay, students. Let's see. Now I will discuss some important reactions that is very important for electrophilic substitution reactions. Electrophilic substitution reactions. Now one important question is, for example, a benzene ring having two electron donating groups are present are ring activating groups. This is electron donating group and this is also electron donating group. This is also electron donating group. But NH2 is a strong activating group. Activating group, then OH. This is on electrophilic substitution reaction. The electrophile is Cl plus. The E plus is a Cl plus. What is the major product? That major product means NH2 is strong. That's why this electrophile will be attacked at para to the NH2. This is the major product. OH bond Cl bond NH2. This is major product, dear students. And the minor product is the chlorine will be attacked to the para of OH group and ortho of NH2 is a minor product. Okay. Now, this kind of questions are very important. Two substances are present on the aromatic ring. The substance nature is donating group, both are, then where the electrophile will be attacked. The two substances are present. One is electron withdrawing group. Let's say another model. One is electron withdrawing group. The second one is electron donating group. They are in 1 and 3 position, meta position. 1 and 3, the resultant electrophile will be attacked always para to the electron donating group. The electrophile is substituted at para to the electron donating group as a major product. Okay. So when whatever that group strengths, one is electron donating group, another one is electron withdrawing group is present, then that the resultant product is NO2 and Cl bond OH. This is a major product. The minor product is NO2. The electrophile cannot be attacked at meta to the chlorine. This is a minor products. And one more minor product is also present. This NO2 will be the Cl plus, it is OH to the para. This is also minor products. So the major product is always that electrophile whenever two groups, one is electron donating group, another one is electron withdrawing group is present at 1 and 3 position, the electrophile will be attacked para position of electron donating group.